should be amazed by C. When you cube this number, it's a complex number, you get 8. So therefore it's like a cube root of 8, isn't it? You know, you're familiar with 2, and when you cube it you get 8. But this is another number like 2. It's like a friend of 2. It's not equal to 2.
How does that work?
But it's another number that's like 2 that when you cube it you get 8. Apparently, I mean all I'm just saying is what it says there, right? When you cube it you do get 8. So it's like a family friend of the number 2. There's something special about it though. It's not every number that you cube and you get 8. So I just want to stop and just kind of smell the roses on that one. Okay. We are gonna start our discussion today about complex numbers, and you might be thinking this is the last unit of the year. It's probably just like a catch-all unit, right? Do some polar, do some complex, just to like kind of round out the year.
Sounds good.
But what you don't see is that there's like a beautiful connection that's gonna come between these. There's a reason they're together this year. You'll start to see it today, and you see it blossom as we move forward into tomorrow and the next day. Let me show you a picture from. Well, I don't know. Can you tell me where I took a picture that scanned this in?
Were you at a wedding?
I was at a wedding. Yep. And this was a.
Was it
This
the
is
McDonald's?
This is my table card. No, I think I sat at table pie at their wedding.
Okay.
Or maybe you. I can't remember. I have some pictures of the table cards at their wedding.
You went to
I can pull
Last
up.
wedding?
I can pull up my photos of all the table cards at their wedding too, because I had to.
Wait, this is for real?
At Mr. McDonald's. No, this is actually Mr. Davis's wedding, who you haven't had yet. Mr. Davis and Mrs. Davis, who runs theater. You know, you'll have Mr. Davis for either BC Calc or for higher level math, and he's one of the upper echelon when it comes to RM teachers. You're gonna love him. Okay, but they had different, like English. She was an English teacher, so they had English tables and they had math tables, and there was like I think the English ones, maybe it was like author and you had to find a book or book and then author or something like that. Little puzzle. I think for most people the math problems were easy, but for math teachers they give them, this isn't that bad though. What table did I sit at? Yeah, table -1, right? So I really did honestly sit at table -1. Yeah. All right. Huh? Yeah. He's busy. But I'm gonna no, I'm for real. Actually, I might have it somewhere. I could pull it up. I would not make something like that up. I know. Like Chicken Little or something. Yeah. Or what? The Boy Who Cried Wolf or whatever. Okay. So I'd like you to continue on there and do these other problems if you haven't done it. Let's just try and get our legs back under us as far as complex numbers go, and just believe me that something beautiful will occur in the future here. How do we take the 30th? I'm interested to know when it comes to D, which is on the next slide here. How do we divide complex numbers? Our goal on all of these, sorry, the instructions aren't very clear, but the goal would be to write, in the end, write whatever the problem is, simplify it so fully that we can write it in the form something plus something times I, right? Like every single one, that should be our end game. Okay, so how are you doing on those? I'll call some people up for A, B, and C now.
I do see.
Yeah. For that one. Out. Whenever you're ready. Let's go. C. Anytime you're ready, any one of you can put those answers up. Something
Oh wait, I just did this one.
some real number plus some real number times I.
6I minus
come up, check your answers for both things.
Thank you.
Excuse me.
My dad really likes those
How do you
candies.
write without writing over your?
He likes the candies Atomic Fireballs. So,
How do you write over without like?
what do you need?
When I'm writing, I cover it.
Here, right.
First of all, you can write even without covering it. You're talking on the board and not the. Oh, that's true.
Yeah.
That's true. This feels weird though.
Mother's Day.
Oh, that feels weird. Okay. Anyway, sorry.
I made something like
That's stuck in my head because I don't know why, but yeah.
I had to leave this of his photographs, and now I'm taking everything, flipping it over here.
A minus I.
I knew you did quotation
I
marks.
minus.
Unless you use sector.
Took a lot of space.
Yeah, I don't know how I feel about the quotation marks, but okay. The ditto
Oh,
marks.
isn't that like what happens when you like want to not write it, but it's like something?
Yeah, but I don't know.
Oh, I'm sorry. I got lazy.
Rachel, you don't have to do these. Yeah. You have to resolve that.
That's weird.
Alright, I'm gonna make these go away in a second. A, B, and C. Are you okay with those? I mean, yeah, they're called A, B, and C, right?
Does it matter what I wrote it?
C.
Oh, someone, okay. What do I do?
I'm gonna make A, B, and C go away in a second. Anyone still need those? Are you good? By the way, the only one that I want to maybe highlight is C. Do you know how to resolve I to the 30th? Do you understand how that works?
Figure out what it is.
There are a couple ways of resolving that. I'm just reading Isabel's mind here. It looks like she's like, hey, that's I squared to the 15th, and I know I squared is -1, and then I know how to take -1 to the 15th. That's a nice way to do it. That isn't actually the way I first think to do it, but like it's also efficient. Yeah.
Yeah, you divide by
I think of it as I to the 28th times I to the second. All right. Anything else on there, Sue? Before I maybe go.
I mean, I wrote
No.
a bunch of extra work.
Are these right, by the way?
Yeah.
Okay, good. I just want to make sure at least that they're right. All right. Okay, and then we'll get Rachel here, and Thomas here, and I haven't decided who's there. How about Anna? Anna M. There.
I did it there too. I did it there. I didn't do it there.
When you're ready.
Yeah, I'm gonna bring this up because I know I'm gonna make that mistake again. Make sure no one else will over going down. I don't want to TV. That's okay.
Help each other out with these. It's been a while, maybe. Since you've gone through. Yeah, that's a good way to start it. That's called. Good. Good. So, people out there, how do you divide when you're dividing by a complex number?
You have to multiply by the complex
You have to multiply by the what?
The complex
By the complex conjugate over the complex conjugate, aka multiply by 1, is what we really mean. But yeah, you remember that word?
Yeah.
Those words. Complex conjugate. Okay. So that's what you see Rachel doing and D. Thomas is also doing that and E. Anna will come up here in a second too. I believe in you. This should feel kind of like
Oh, true.
I got 30 minutes.
Did you multiply by that I?
Yeah. Did I not?
There's another I outside the box.
Did I completely drop that? Oh shoot. Did I? Yeah. Oh. I put the item on the I put the negative right next to the item. Yeah. I didn't. Theoretically, you should in your end, but like. Yeah, let's at least split it, but it's really necessary to last.
When you're done, come up with a harder problem for yourself, you know? If this stuff bores you, then take something up instead.
Are you on problem?
Alright, we're gonna move on here. Are you good on D and E at least? And you understand how to multiply by the conjugate. This should be all review, but I know it's been a while, so there you go. Yeah, sure. Can you write it quickly? Oh, you can write there. All right, Anna's going to write on the board because it's a little bit of work. Did you find, at the very least, that that comes out nicely too? Okay. All right. Not quite as nice as A maybe, but still pretty nice. Lots of things go away. All right. Let's move on then and make sure we're kind of not just reviewing, but saying something more profound about complex numbers. The first thing I might think about is like, what are they? How can I picture them in particular? How can I plot them? Let's think about like 1 plus 2i and ask the question, where does this belong? So where do I put this on the number line? Are you hearing me? Where does it belong?
Well, you go to 1.
It's imaginary. Oh, it's in the imaginary realm.
Yeah, this is a complex number. And the number line I've drawn, maybe I should have more appropriately named, that's the real number line, isn't it? And the answer is, of course, it doesn't belong on the real number line. Or consider a question like this. Which is bigger, 1 plus 2i or 2 minus i, something like that. I just made the numbers up, but whatever. The point is, can you put them in order? Is there any way in which you could order them?
Yes.
You think of complex numbers as being kind of just like, another kind of number, but to what extent does that analogy hold, right? How do we picture them? How can we even put them in order? What does it mean to have a function that takes complex numbers and outputs complex numbers? How can we visualize that? Lots and lots of questions I have for you, right? Like these are deep questions. Yeah.
Will complex numbers, or at least will it be possible for them to be on our IB problem?
Yeah. All right. So the way you picture complex numbers, and maybe some of you have been exposed to this idea before, is by plotting them on something called the complex plane. It makes sense, I think, that we need 2 dimensions because they're 2-dimensional numbers, right? In all the problems you've just done, haven't you boiled them down to something plus something I? You always have like 2 things. For every complex number, it can be described by 2 quantities. They're kind of like vectors, right? Which we picture, if they're 2-dimensional vectors, we kind of picture in a plane also. So we'll embed the real number line. This is the real number line. It still is here, right? So every number you know and love still lives in this picture, just along this x-axis, which we're calling the real number line. And then we also have like an imaginary part. You might be used to calling it a plus bi, the standard form, a plus bi. But maybe we should call it x plus yi. There's nothing special about the name, but just to remind ourselves of what we're thinking about. We can think about this really as 2 dimensions. The overall number we might refer to as z. I think that's the most common letter for an unknown complex number. Just like usually an unknown real number, we denote x or something. Just style points for that, though. So we can picture the real part and the imaginary part as the x and the y coordinate. And then there's a picture of z. Yeah, in the complex plane. Also sometimes called the Argon plane. Named for someone, and I forget the historical detail, I apologize. How do we calculate the magnitude of a complex number? Or, I could even ask, what does it even mean? What do we mean by the magnitude of a complex number? You've used that word before in your life, so maybe yeah. The length, or from where to where. Yeah, the distance it is away from the origin, right? So how do you compute that? Without me telling you first, I'll put it up here in a second. Steven, say what? Right? You've seen that before. In fact, we'll even steal the symbols we've used before. You might call it, you might also call it the absolute value of the complex numbers, right? So one of the questions on our lists up at the top could have been like, what does it mean to take the absolute value of a complex number? Well, we've just answered that one. Sometimes it's also called the modulus if you want to really be fancy and geeky. 3 names for the same thing. lots of rehashing today of things you've already talked about in other contexts. I mean, this is like the umpteenth time that we've thought about the magnitude of something. Here it's in complex number land, but just recently in polar form. Less recently, vectors. Before that, the distance formula. In geometry, we might have talked about the Pythagorean theorem. All the same thing, though. So this is called standard form, is the words you might use to call like a plus bi, or the thing you've been doing on these problems on that worksheet. You might have called standard form, but let's also call it rectangular form. Is that okay? Given our new interpretation visually, geometrically, of what's going on here, maybe rectangular form is a good name for this too. X plus yi. And I want to make sure that we see too that really this set of numbers, these complex numbers, it's sad that they're called imaginary numbers. That's kind of just an artifact of history. There's nothing abstract about them any more than the other numbers you've met. They're perfectly concrete, and I can point to them. There, right? I can picture them, and they're useful in concrete ways in the real world. There's nothing really imaginary about them. They're just two-dimensional numbers. That's all they are. They're two-dimensional numbers.
I don't believe you.
Well, you can just get over it then. No, I mean, there's a conversation to be had there, but in no sense, you either could go one of two ways. You could say that everything, they're equally real, as our real numbers are, or you could say that all numbers are imaginary, right? That would be a fine way to say it too. But I don't think that anywhere in between is a tenable philosophical position. You have to take one of the two extremes. Okay. If you would do this for me, I'll call someone up in a second to do it. Like you, Maddie. Not meant to be like crazy here. Let's just practice plotting the number and find the magnitude too, if you will.
I always find it funny when they say that infinite series that versus is equal to another infinite series. Like I get that it's legit. It is always funny to listen to because it's like it's always just weird.
Yeah, we didn't lots of rules that we can break.
Why not?
Whenever you're ready, man, you can put it up. No wait for anyone.
And they're really good times and stuff. And it's like the sum, like one
Yeah, that's where
over
it belongs. Good.
one
And then find the magnitude.
1 over 2.
When you get it, when you get a pretty picture, you find the magnitude, show your neighbor, make sure you get the same thing as they did.
Minus 7. And that equals something. I think it was 1 plus 2. Like, oh yeah, that makes sense. Right? Actually, I don't know. What did my game equal?
That would make sense. That's making it smaller than 17.
But average value.
'Cause All right. Yes. Agree. 17 is the magnitude. You're welcome for that Pythagorean triple. You're welcome. That's for that nice Pythagorean triple. Isn't that nice? Didn't see that coming, maybe. Okay. If we could think about numbers, complex numbers, in rectangular form, maybe that already invites us to think about them in polar form too. So maybe already you're seeing some connection here, but it might seem a little bit forced today. I promise though, soon you'll really like polar form. You'll really like polar form. You'll go out of your way to put it in polar form, even if I don't ask sometimes. So just like when we're thinking about rectangular polar form, when we're not in the context of complex numbers, we're interested in knowing for this particular value, this particular z, this complex number, what its r and theta value are. What is r? How do we compute r? Or what is that equal to that we've already discussed today? Yeah. All right. So r would be the magnitude of the complex number. And theta would be, well, we'll have to figure that out in ways that we already know how to do, right? We often factor out the r, just because you can, just for fun. And so this is polar form in the box. R times the cosine of a given angle plus I times the sine of that exact same angle. And since it's always the same theta here and here, and if you're writing it in polar form, it gets a little cumbersome to always write this out. 10 times cosine 45 degrees plus I sine 45 degrees or whatever. Sometimes you could abbreviate it like this, r cis theta, which means cosine of this angle plus I times the sine of this angle. There you go. There you go. We'll have an even better way to abbreviate that soon, but that's polar form, right? Cosine of the angle plus I times the sine of the angle. Cosine I sine. Yeah.
Did that allow?
It's not that important that you can just always write it this way. If you get tired of writing it like we have it in the yellow box, feel free to abbreviate it. Cosine plus I sine.
Wait, why do we write this?
I'm just saying you don't ever have to write it, Justin, just ignore it. Okay. Where, like we said, r is the magnitude, and the angle is gotten using some trig. And again, if you want to be geeky and cool and fancy, then you might use the word argument for theta. So sometimes people call it, instead of polar form, they would call it like modulus argument form. R and the theta value. That's what you'll, if you take higher level math, we'll use that language. Modulus argument form, or whatever. Fancy words that mean simple things. Okay. So we've introduced a lot of vocab in the last couple slides. Are you good with all this stuff coming at you?
Yes.
No. Thank you for that acknowledgement, Charlotte. I appreciate it. I like the interaction. The argument of the log is a thing that you stick into it, right? So that's kind of like what you stick into it here too. It's also it's also the thing we put into a function, right? The argument of the function. And computer science too. They stole the math word.
I think math is a good science word.
Maybe.
I think it's a good science word.
Most things in computer science are called math, so you know. All right, let's show how this can be converted to polar form. So, again, just think, how would you convert the coordinate if I asked you on the quiz, convert the coordinate in rectangular coordinates, negative 320, comma, negative 320. Convert that sort of polar form with r and theta. That's the same task here, find r and theta, right? What is r? How do we compute that? Oh, yeah, let's see. Square root of... What does that come out to? Something big, but what is it? 320 root 2. Are you good with that? right? All right. What about theta? Well, theta is the angle that has a cosine of negative 320 over 320 root 2, right? By definition of cosine. You remember the definition of cosine is x over r, right? Like go back to day 1 of cosine, right? Back when we birthed this function. That was the name we gave it, x over r. And the sine is the same. So what angle is this? What quadrant are we in? Yeah, so theta equals 5 pi over 4, I hear you say. Which, by the way, I should just be clear. The answer I'm about to write down, once you get used to what we're doing, just going visually on this, I probably would just write this answer down. I probably wouldn't show any of the work I just showed if it's an easy angle like this. I'd probably be like, yeah, I think I know the magnitude of that is 320 root 2. And I think I know just from plotting it in my head that it lies in the third quadrant at 45 degrees, you know. So maybe I can just write it down. Here we go. Z equals 320 root 2 times the cosine of 5 pi over 4. This is what we mean by polar form. Plus I times the sine of 5 pi over 4. Or, again, if that becomes cumbersome, keep in mind that the angle here and here will always be the same angle. So if that becomes cumbersome, you get tired of writing it, you can write 320 root 2 6 5 pi over 4 if you like. Knock yourself out. If you multiply this back out, do you get the thing you started with? I mean, hopefully, if we're right, if we did right. You just evaluate cosine of 5 pi over 4 and multiply it by 320 root 2, and you should get negative 320, for example. Okay, let's do one more before we go. Convert a polar form to a rectangular form in the way I actually just described, right? Just multiply it out. Evaluate the cosine, the sine, and multiply by 22, and just walk away. For this, we need to remember what the cosine of 5 pi over 6 is, and the sine of 5 pi over 6, what is it? Negative root 3 over 2, I like. I love seeing that. That's the coordinate of that point on the unit circle, right? Negative root 3 over 2, comma 1/2. 5 pi over 6, I should, right? Anyway, so what do we get here? Negative 11 root 3 plus 11i. There it is back in like rectangular form, so to speak, right? That's it. So not right now. It's just like a matter of curiosity, but just stay tuned. Hold my hand as we walk this path, and you'll see something beautiful happen. Okay? I'll miss you. Good luck on your AP Stat test. Those who won't be here. You can catch the video online. Survey.